Hi. Now the last I will show, that is the NOT gate. It is quite interesting. Okay, see the NOT gate. How I shall do the NOT gate. For this NOT gate, I will use the AND gate only. But we have to change something, and we also have to delete something in the code. Changing and deleting will be done simultaneously in the AND gate with the help of the AND gate. Okay, so let's dive into the NOT gate. Now let's do the NOT gate. Now see, NOT gate. So let's first change the entity AND gate to NOT, then end entity as AND gate to NOT. Now NOT gate. In the NOT gate we need only one input, right? Means A not B. It can't possible. Means it can be possible or it can't. But for the NOT gate we need the one input. Means not A. For the A, when the input is 0, then what we shall want as the output in the NOT gate? That is 1, means 0. That means after giving the NOT gate, the output have to be 1. Again, for the 1, the output must be 0. So we need this type of output. For the input 0, we want 1. For the input 1, we want 0. So for this, we need only one input, not two. So we can delete this input B. You can delete the A also, anyone. You can delete the B or you can delete the A, anything. So I am in this, for now I am deleting the B, and I am keeping the Y part because this is the output. We need the output, no. Now in the behavioral part, we will first change the AND gate into NOT gate. After changing this, in the begin part, we have written as A and B, but we have taken only one input, right? So we will delete, or yes, we will delete this A and B and write as not A. So the output will become the not A. Means whenever the input A will become 0, the output will be the output which will form in the EP wave diagram will be give us 1. Again for the input 1, the output will be 0, like this way. Okay, so this design part is complete. Now in the test bench part, we will again change the entity part as NOT gate, again end entity part as NOT gate, again architecture behavior part as NOT gate, and again in the input means component part, mean the data sheet part where in the box all the data, all the materials are present. We will also change the name NOT gate, and we will delete the B portion, B input. Okay, A and Y will be the present. Now in the signal part, we will make that in the signal part. So in the signal part, we will keep only the A part. We shall delete the signal B part. Okay. Now in the begin UUT means the unit under test part, we will change the name AND gate as NOT gate. Now in the port, we will delete this B part once again. Now in the process part, this process part we will make as A as 0, and we will delete the TB0 and wait for 10 nanosecond, and we will keep this, we will delete the next portion, and we will delete this TB0, and we will delete this 1 portion. Okay, so for the NOT gate we only need two things. TB underscore A equals to means this is less than equals to means 0 is assigning to the TB underscore A. For that reason I have we have to write as less than equal to. So TB, the 0 is assigned to the TBA. Wait for 10 nanosecond, one output will be occurred in this situation, and in the next TB underscore A, in the one situation another output will be occur. So we need only two inputs, 0 and 1 for the A only. So this all thing will be same way to end process, end architecture behavior. Okay, so this is the NOT gate. Now we have to change the means write the entity part. Let's copy the TB NOT gate, then paste in the top entity. Now let's run it and check whether it is correct or not. See, simulation has finished. See, This is the EP wave diagram for the NOT gate. See, for the 0, the output is 1. See, test bench output is also 1 and normal design part output is also 1. Now for the 1, see, output is 0, design output is also 0. So this is the NOT gate. Okay, so by this you can we can conclude that our hardware is fully completed and fully correct one. So this is the NOT gate. Once again, in the end, I will suggest that go and check the basic of the EDA Playground as well as the AND gate. All the links I have already shared in the description box, so go and check it. Then after that you can understand this all of this basic gate. So in this video, by including the previous one AND gate and this video, we have completed all the basic gates. Now I shall upload the more video including more sequential and combinational circuits. Okay, so till then, stay tuned and keep learning. Okay, bye bye.